Okay, welcome back, guys. So we have another question from chapter 2 of the Beer and Johnston textbook, and we have two different questions which are around the same figure and same setup. So we have first question 222. We have to determine the x and y component of the force shown on this pen, and at the end we need to determine the resultant of these three forces. Before we start, please make sure to subscribe to the channel, and we've been doing a couple of these kind of questions in the channel. Feel free to check out the previous videos if you need more practice and you want to see more questions about vectors. And let's get started. So we have what we are looking for at the end is the resultant, which consists of the Rx, which is the sum of all forces in x direction, and Ry, which is the sum of all forces in y direction. And what we are looking for at the end will be the magnitude of the R and the direction. So let's call the three forces in here. We have the 40 pounds force, we have the 60 pound force, and we have the 50 pound force. Let's start with the x component of the 60 or the 40 pound force. So since we have the angle for each of these forces with x and y direction, so as long as we have the angle with x axis, the cosine will be the x component. So here we have, for this force, we have the angle between the force and x-axis, and we can see that the x component, which is this one, will be positive since it's to the right side. So we have 40 times cosine of 60 degrees. As for the x component of the 40 pounds force, so if we calculate this, we know the cosine of 60 is 0.5, and 40 times 0.5 will be 20 pounds. So we are trying to find the Rx first. So we are going with the x component of each of them. So x component. Let's move on to the 60 pound force. Again, we have the angle with the x-axis 25 degrees, and we see that the x component is this one, so it is to the right. So again, we have a positive force, 60 times this time cosine of 25 degrees, and this would give us 54.38 pounds. And the last one is the 50 Newton force, and as we can see, we have the angle with y-axis. This will be our angle with x, which is 40 degrees, 90 minus 50, and it, as I said, it is negative, so we have 50 times cosine of 40 degrees or sine of 50 degrees. And if you calculate this, we'll get minus 38.30 pounds. So now that we have everything, the sum of all these three would give us the Rx, which will be 36.08 pound, and that would be our Y. So far we found the first part, or the Rx component. We'll need to do the same thing for the Y part, and I'm just going to clean up everything and we'll do the Y component after this, and I'm going to show it in red. And now we are trying to find the Ry. Let's start with the 40 Newton force again. So this will be our Ry for the 40 pounds force, and as we can see it is negative 40, and the sine of angle with x-axis would be our y component, so this will be minus 34.64. And for the 60 pounds force, it will be this force, so we have this force as our y component. We can see it's positive, and 60 times sine of 25 degrees, since we have the angle with x-axis. And if we calculate this, we'll get 25.36 pounds. So again, we are finding the y components of each, and at the end we need to add all these three amounts together to find the Ry. And the last one is the 50 pounds force, which will be this force over here. The y component will be this force that I'm showing in here. Again, we'll see that it's downward, so negative. The magnitude is 50, and if we want to find the y component, we know again the angle with x-axis is 4 degrees, so the sine of 40 degrees will be the y component, and this one would give us minus 32.14 pounds. Again, we're gonna add everything, and this would give us Ry, and we will have minus 41.42 pounds as our Ry. So now we found Rx and Ry component of the force, and we're good to go to find the magnitude and our direction of resultant, and that would give us the final answer for this question. So what we found at the end was we found 36.08 pounds for y and minus 41.42 for j. So if we look at our r, we'll see that the x component is positive and the y component is negative. And what we have for r would be this vector over here, which we call it r. So this was our rx, which is to the right since it's positive, and ry is downward since it's negative. And we can call this angle theta, and if we want to find theta, we know that tangent of theta will be ry over rx, which was, again, we don't care about, so just one thing in here, we are looking at this triangle, the right triangle that we have in here, and we don't need to be worried about the signs. We know the magnitude of this side is 41.42, and the magnitude of this side is 36.08, and we are considering this right triangle here, and we are looking for this angle. So we don't need to be worried about the sine of rx and ry. We just put the, so if you want to find the theta, we'll have the tangent reverse of the magnitude of ry, which is 41.42 divided by 36.08. And if we calculate this, we'll get 48.9 degrees for the theta, and our final answer for r would be, so we need to find the magnitude, which is rx squared plus ry squared, and we'll have 41.42 squared plus 36 point, and this would give us the r, which will be 54.9 pounds. and we already found this angle here from this right triangle, and we know the angle was 48.9 degrees. And this will be the final answer for the resultant. We need to show the magnitude as well as the direction of the resultant. So that would be all for this question. Please make sure to subscribe to the channel and let me know if you have any specific question from the textbooks that we're covering in this channel, and I'd be happy to cover it in the next videos. You guys have a good one, and I'll see you in the next video.